Hi everyone. So we are now going to get back into factoring. We talked about factoring perfect cubes in the last lesson. So now we're going to move into factoring higher order polynomials using known quadratic factoring procedures. So this is things very similar to what we've done in the past, but they look slightly different. So it's just about recognizing it. So here are 3 problems that I'd like you to try. So this is x to the third plus 5 to the third. So that's the sum of 2 different cubes. So we've got x plus 5 and then x squared. Remember it minus 5x plus 25. That's it. And then the next one, this is 2x to the third minus 3 to the third. So we get, since it's a minus, we have 2x minus 3, right? The binomial sign follows the sign of the original, and then we square the first, 4x squared, plus multiply the 2 terms together. 2x and 3 gives us 6x, and then square the second term, so 9. 3 is a little different. We did these a while ago. This one is a dots. It's a difference of 2 perfect squares. Right? So what times itself is x to the fourth? X squared times x squared, and then plus 8 minus 8. Can we keep going? We don't normally, you can. We can make this x squared plus 8 we're done with, right? What we can do is make that x plus root 8, x minus root 8, if we really wanted to. We could even make, which is actually x plus 2 root 2, x minus 2 root 2. I like doing those in class. I think they're fun. Oops. All right, so now let's look at some new ones. All right, x to the fourth plus 7x squared plus 10. So think about, what does this remind you of? This looks really similar to x squared plus 7x plus 10, which is a basic multiply combine chart. But it's x to the fourth and x squared. But it's really the same process. So it's x squared times x squared is x to the fourth. And then when we FOIL this out, right, 2 and 5 multiply to 10 combined to 7. When we multiply this out, we get x to the fourth, 5x squared. Hope you can hear my dog in the background crying. So the fact that the middle term is 2 and the first term is a x to the fourth makes it so that this works out. So this is our answer. All right, so pause the video and try the next one. All right, so for this one, it's pretty much the same process. So what times itself is m to the 8th? M to the 4th, m to the 4th. Now that's important so that when we FOIL it out, we get m to the 4th in the middle. We're multiplying to negative 12, combining to negative 1, 3 and 4 with a negative 4. But wait, there's more. X to the fourth minus 4 can factor again. How do you factor m to the fourth minus 4? How do we factor this? That's a dots, just like they do now. M squared plus 2, m squared minus 2, m to the fourth plus 3. Are we done now? Technically, we can factor this as m plus root 2, m minus root 2. Technically, would I make you do that on a quiz? No. But we can do it. It is possible. It's not impossible. It's just not real numbers anymore. Just kidding. Not rational numbers anymore. Square root of 2 is a real number. It is not a rational number. Okay, so to recognize when this is possible using this method, it's a trinomial, and the degree of the middle term is exactly half the degree of the first term. That has to happen, otherwise we're going to have some other method that we'd have to use. All right. So pause the video and do these. So these are slide problems, right? So I have 2n. Here, I'll do the slide and then I'll do it in my head. 2n. So we are multiplying. We take our 2 and our -7 and we multiply them. So multiply to -14, combine to the middle term. 2 and 7 with the 7 negative. So +2 -7, and those are 2n squareds. Divide by our GCF. So we get n squared plus 1, 2n squared -7. And again, you could factor that second one using dots. It would be really obnoxious though. It would be square root of 2n. Oops. It would be the square root of 2 times n plus √7. Square root of 2n minus √7. So that's just annoying. I mean, I know I like to go a little crazy with these, but that's pushing it. Okay, 3x to the 10th plus 13x to the 5th plus 4. So this one I'm going to do without the chart. So I know it's 3x to the 5th and x to the 5th. I need to get to 13. If I multiply 3 times 4, that gives me 12 plus 1. And everything is a plus. That's it. All right, now we're going to get a little more complicated. Pause and make sure you factor as much as you possibly can. So this is a basic MC chart. Multiply to 36, combine to 5. So we have w squared and w squared. What multiplies to 36 combines to 5 is 9 and 4. Our 9 is negative, our 4 is positive. But then we can factor w squared minus 9 as w plus 3, w minus 3, that's a dots, and w squared plus 4. So now I'm going to throw in another extra piece just to be the obnoxious advanced math teacher. W squared plus 4, you can treat that as a dots if you use imaginary numbers. Think about if you tried to solve w squared plus 4 equals 0, you get w squared equals -4, w equals plus or minus 2i. So you could actually factor that as w plus 2i, w minus 2i, and then your w plus 3, w minus 3. It's kind of taking it slightly too far, but so don't think that that's not impossible to factor. It is possible. It's just kind of annoying. All right, next one. So k to the 4th, so we have a k squared and k squared. Multiply to 16, combine to -17, minus 16 minus 1. Both of those are dots. So k plus 1, k minus 1. And then k plus 4, k minus 4. So that's a nice straightforward one where you end up having dots left over. All right. Again, pause the video and try these on your own. So w to the 6th, or y to the 6th. So we're going to have y cubed and y cubed. What multiplies to -40 combines to -3. That is 8 and 5. And then the 8 is negative, the 5 is positive. But wait, there's more. These are not perfect. This is not dots, but what is it? Y to the 3rd minus 8 is the difference of two perfect cubes. Y to the 3rd minus 2 to the 3rd. So now this one is a have to. This is not like, oh, Miss Fazone is just being silly. No, this one I expect you to factor that out. So y minus 2, y squared plus 2y plus 4. So sometimes we will have a difference of two perfect cubes, and that's why I taught that first. we specifically went over that so that we could do these. All right, so now if you didn't finish number 8, pause the video and try that. So we've got m to the third, m to the third. Let's see, we got 5 and 1. 5 is positive, 1 is negative. 5 is not the difference of two perfect cubes, but 1 is, so we can rewrite out that one. So I'm going to write the m cubed plus 5 in front. So it's a subtraction, so m minus 1. And then m squared plus 1 times m plus 1 squared. And that is our answer. I don't know why, but I really like doing these. I think they're fun. All right, last page. Try these on your own. So just the fact that I see w to the 6, and I'm like, okay, so I'm going to have a w cubed. I'm going to automatically look out for it. Just like if I have an xn to the 4th, like in the next one, just the fact that that's an 8th, I'm like, oh, is this going to be, might be a dots in there somewhere. So 8 and 1, 8 times 1. So now both of those are the difference of two perfect cubes, or the sum of two different cubes. This is w cubed plus 2 to the 3rd, and w cubed plus 1 to the 3rd. So we're gonna have a lot here. So we get w plus 2, w squared, we multiply the 2 together, oops, minus, change the sign, minus 2w plus 4, so that's this guy, and then we have our 1, you can even read that, that's to the 3rd, so that's w plus 1, w squared, minus w plus 1. And that is the final answer. You can never, these are not factorable. Those are never factorable. You can try, but it's not going to work. All right. Last one. N to the 4th and n to the 4th. I would put money on these being a dots problem. All right. 32 to 18. So that's 16 times 2. One's a plus. They're both minus. All right, so now this one, it depends how you can factor this one as n squared plus root 2, n squared minus root 2. You don't have to. If you want to do that, you can. You don't have to, though. The other one you have to factor, though, n squared plus 4, n squared minus 4, and then we actually have one more after that. So I'm going to leave my final answer as n squared plus root 2, n squared minus root 2, n squared plus 4, n plus 2, n minus 2. Or if you want to go even further, I know, you guys are just rolling your eyes at me. I'm okay with that. So for n squared minus the square root of the square root of 2 would be n plus the 4th root of 2, n minus the 4th root of 2. And then for n squared plus 4, you could do n plus 2i, n minus 2i, n plus 2, n minus 2. Oops. That's the most intense version. That if you want to go for it, you don't have to. Here's the version, I'll write down in green, the version that you need. The version that you would need would be n to the 4th minus 2, n squared plus 4, n plus 2, n minus 2. That's the minimum amount of factoring. This is like fun. I know, you guys are rolling your eyes at me. It's not fun, but it's fun to me. Because I got that down as much as I humanly possibly could. I only have linear, well, I have a couple. Oh, for that one, n squared plus 2, we could make that an I. It could be n plus I, the 4th root of 2, n minus I, the 4th root of 2, if we really wanted to go even further. But this one right here, that's your answer. All right, homework, nice short lesson. Have a fabulous day. I will see you on Tuesday.